Episode 6, Applied Multithreading. Welcome back. This is the 6th episode in Compensation Behind the Scenes, a series where we go in-depth on the internal workings of our multiplayer social game Compensation and talk about some related computer science along the way. Real quickly before we continue, we have a list of some acronyms we're going to use up on the screen. Take a look over these if you're not familiar with them. In this episode, we'll be going over the applications of multithreading inside Compensation, how it helped us, and how it hindered us. Without further ado, let's begin. Inside Compensation, oftentimes we have the need to perform multiple tasks in parallel, whether it's waiting for the GPU to render a frame or waiting for an HTTP request to our API. We often have time being wasted on one thread while it blocks for a task. We can recoup some of this time by using multithreading. Now that we've cleared up why we need threading in Compensation, let's get into some actual examples. Oftentimes, we need to wait for an HTTP request to finish before we can do something. Other times, we'll receive a message from our WebSocket server while we're still rendering a frame. In this case, we need to use a thread so we can still process the incoming message while working on other things. Let's look at an example. Here, you can see the code for making an HTTP request using our API wrapper. We use the async and await keywords to specify when the thread should stop and work on other things, and we use the task structure to control threading, as it is more efficient than using threads directly. After making the request, we check the response and then print out the nickname of the player whose profile we looked up. Here, we see another example of threading. In this code snippet, we display a message from the server whenever we receive it. However, in this case, we aren't actually explicitly using threads. In this case, our WebSocket implementation automatically spawns a new thread whenever a message is received. For that reason, we cannot access any part of the Unity engine code until we're on the main thread. So, we use a handy utility called Multithread to run an anonymous function in the main thread at the start of the next frame. That function then displays the message in the text. Sometimes we have an extremely large list of data that we need to crunch through. This is often the case with things like vertex caching, where we need to iterate over every face in a mesh and calculate the center of it. For that reason, it can often be useful to thread it, so we can do multiple times the work in the same amount of time. In this example, we'll do exactly that. You can see some of the code here. I won't go in depth on the actual vertex math itself, but you can see how the control flow works and how we avoid causing any memory issues. First, we allocate exactly the amount of memory we'll need for this process. Then, we set up each of the tasks in turn. After that, it's just a matter of waiting for all of them, then returning the processed results. Each thread would theoretically get its own slice of the array to work on, and would only have read access to that slice, preventing memory corruption. At the same time, it only has write access to its own slice of the output, again preventing memory corruption. Of course, this isn't an accurate representation of the Unity API, and in some cases, such as small sample sizes, this would actually be less efficient than a single thread. A few things to keep in mind for multithreading performance. Firstly, all threads should be as separated as possible. Ideally, they work entirely independently and only output the final result. Of course, you can't always do that, but it's something to aim for. Secondly, anything involving locking or blocking has the potential to slow things down significantly or even lock up entirely. Thirdly, once you have more threads than the CPU actually has, you start getting diminishing returns on speed. Finally, look at your problem. Do you really need threads, or are you just optimizing prematurely? As I said last episode, multithreading is an incredibly useful tool in the programmer's toolkit, but only when used properly. When used improperly, it can rip your program to shreds, especially in lower-level programming languages like C++ or C. With that being said, make sure to tune in for the next episode, where we'll go into a deep dive on compensation matchmaking and how it affects your experience. Thanks for watching.